You can often spot an AI image by looking at the hands. The face may look cinematic, the lighting may look perfect, the clothes may have tiny textures. Then you zoom in and find 6 fingers, melted knuckles, or a thumb pointing in a direction that makes no sense. Hands feel especially disturbing when they are wrong because we see them every day. We use them to eat, write, wave, text, point, and hold things. Your brain has a very strong model of what a hand should look like, even if you have never studied anatomy. The weird AI hand is not just a funny internet glitch. It tells us something important about how image generators work. These systems can create convincing surfaces, but they do not understand the world in the same way a person does. A human artist usually knows that a hand has bones, joints, tendons, and fingers connected in a specific structure. An image model learns differently. It studies millions of pictures and learns patterns in pixels. It learns what hand images tend to look like, not a physical hand model with rules inside it. Most modern image generators start with random visual noise. Step by step, they remove that noise until an image appears. If the prompt says a person holding a flower, the model tries to shape the noise toward patterns that match those words. A hand is a small object with many moving parts. It can open, close, twist, overlap, bend, grip, point, or hide behind something. A face also has complexity, but faces usually appear in more stable positions. Hands can look wildly different from one moment to the next. Think about taking photos of your own hand. Palm up, palm down, fingers curled, thumb hidden, 2 fingers crossed, 1 finger behind a cup. All of those are valid hands. For a model, that huge variety makes the pattern harder to learn cleanly. With clouds, hair, fabric, or tree leaves, small errors can look natural. A few extra strands of hair do not bother us. But hands have countable parts. If 1 finger is missing, doubled, or fused, the mistake becomes obvious immediately. Image models are not naturally good at counting objects in a precise way. They may learn that hands often contain long finger-like shapes, but that is not the same as enforcing exactly 5 fingers arranged around 1 palm with 1 thumb. If this kind of explanation helps you understand AI beyond the hype, consider subscribing. We keep things visual, beginner-friendly, and focused on what these technologies actually do. Now, let us get back to why fingers are such a hard test. A real hand is 3-dimensional. A picture is flat. When fingers overlap in a photo, some parts disappear from view. A model only sees the final flat image, so it has to guess what hidden structure caused those visible shapes. Occlusion means one thing blocks another thing. Hands are full of occlusion. Fingers block fingers. A mug blocks the palm. A sleeve covers the wrist. When only pieces are visible, the model may complete the hand in a way that looks plausible for a second, but falls apart when you inspect it. The thumb is especially difficult because it sits at a different angle from the other fingers. It can cross the palm, stick out to the side, or hide behind an object. Many wrong AI hands are really wrong thumbs because the thumb has its own geometry. Image models learn from enormous collections of images and captions. Those collections include good photos, bad photos, drawings, screenshots, cropped images, gloves, mannequins, sculptures, and hands partly outside the frame. The model is learning from a messy visual world, not from a perfect anatomy textbook. Captions usually do not describe every finger. A caption might say, "woman holding phone." It probably does not say, "index finger bent, thumb on left edge, ring finger partly hidden." So the model gets a broad label, while the fine details are left for it to infer. The model often blends patterns from many examples. That works well for general style, like glossy lighting or watercolor texture. But blending hand poses can create impossible anatomy. If one example has fingers open and another has fingers curled, the average may look like a melted compromise. People often ask why AI can make beautiful faces but still struggles with hands. One reason is that faces are central in many images, and people care a lot about face quality. Models and editing tools have been heavily improved around faces. Hands received less special attention for a long time. Faces also have a useful structure: two eyes, one nose, one mouth, usually arranged in familiar positions. There is variation, but the layout is fairly stable. Hands do not have one standard view. A fist, a peace sign, and a hand holding scissors are all the same object in very different shapes. Prompts are powerful, but they are not magic anatomy controls. If you write realistic hands, the model knows you want better hands, but those two words do not specify exact joint angles, finger positions, lighting, camera angle, and what each finger touches. Some people try to fix hands by adding negative prompts like no extra fingers or no deformed hands. This can help sometimes, but it does not guarantee a perfect result. The model is still generating an image from learned patterns, not running a hand safety checklist at the end. Hands are often small in the frame. Small details are harder to generate because there are fewer pixels available to describe joints, nails, shadows, and skin folds. When the image is upscaled, those weak details can become more visible and more strange. A model can make a finger segment look realistic in isolation. The skin texture may be good, the fingernail may be shiny, but the whole hand can still be wrong if those parts do not connect in a globally logical way. Hands become even harder when they interact with objects. Holding a pencil, playing guitar, tying shoes, or gripping a glass requires physical contact. The fingers must wrap around the object in a believable way. That is much harder than drawing a hand floating by itself. In video, the challenge grows. A hand has to stay believable across many frames. If a finger appears in one frame, disappears in the next, and returns as a different shape, viewers notice. Motion exposes mistakes that a single still image can sometimes hide. This is where the word understanding gets tricky. An image model can learn strong visual correlations. It can learn that hands near faces often touch cheeks, or that hands near cups often wrap around handles. But that is not the same as knowing bones cannot bend backward through the palm. AI hands are improving. Newer systems often use better training data, stronger model architectures, image editing tools, pose guidance, and feedback from human reviewers. Some workflows also use control images or 3D references to guide the hand shape more directly. Professional creators often do not accept the first image. They generate variations, choose the best one, crop around errors, repaint problem areas, or use separate tools to fix details. A polished AI image may involve plenty of human judgment after generation. A strange hand does not mean the entire image is fake with absolute certainty. Real photos can have motion blur, odd perspective, gloves, shadows, or unusual anatomy. And AI images can sometimes make good hands. The hand test is a clue, not a perfect detector. AI hands remind us that realistic appearance is not the same as reliable understanding. A system can produce something that looks convincing at first glance, while still missing the deeper structure. That lesson matters far beyond fingers, especially as AI images become part of news, advertising, education, and entertainment. When you inspect an image, look for more than finger count. Check whether the thumb attaches correctly. Check whether joints bend in possible directions. Check whether fingers interact with objects naturally. Also look at text, reflections, earrings, glasses, and background details, because AI errors often appear in small, structured areas. Over time, AI hands will likely become less strange. Models can be trained with better examples, guided by pose maps, and connected to stronger 3D reasoning. But the deeper challenge will remain. Making pixels is not the same as understanding the physical world behind those pixels. So the next time an AI image looks almost perfect, zoom in on the hands. They are a small detail, but they reveal a big truth about how these systems learn. If you have a question about AI images, or you want a future video on another AI mystery, leave it in the comments.